In this vast and boundless universe, every flicker of light is a wandering fragment of history. In 2024, a silent journey began as an astronomical satellite, a collaborative masterpiece between China and France, broke through the atmosphere carrying the world's most advanced detectors. It did not venture into the void for clamor or fame, it went to listen. This is a long story, one best shared in the quiet of a dream, but before we begin, remember to engage with our journey as we listen to the most distant reaches of the cosmos, to signals that have remained unheard for billions of years. This satellite was entrusted with an extraordinary mission, to detect gamma-ray bursts, or GRBs, which are among the most transient, violent, and mysterious phenomena in existence. What exactly are these gamma-ray bursts? They represent the most intense energy releases known to science. A typical burst can release as much energy in a matter of seconds as our Sun will emit throughout its entire 10 billion year lifetime. Physicists categorize these events into two primary types. The first is the short-duration GRB, lasting less than 2 seconds and usually triggered by the collision and merger of two neutron stars. The second is the long-duration GRB, lasting more than 2 seconds, typically resulting from the collapse of a massive star into a black hole. The specific burst captured by this Sino-French satellite was a short-duration event, signifying that in the early universe, extreme interactions involving compact objects like neutron stars or primordial black holes were already occurring. Because gamma rays are high-energy electromagnetic waves that can travel across staggering distances, they serve as vital beacons for probing the ancient universe. However, they are incredibly rare and fleeting. Even with thousands of telescopes watching from Earth, the chance of capturing a clear signal is slim. Thus, detecting a signal from 13 billion years ago is not just a stroke of luck, it is a triumph of human patience and technological pioneering. Behind the cold data lies a profound miracle, a resonance with the heartbeat of the distant cosmos. These bursts are the final roars of dying stars. The signal captured here traveled for 13 billion years. To put that in perspective, at the time this light began its journey, the universe was only a few 100 million years old, an adolescent cosmos where the Milky Way had not yet fully formed and our Sun was not even a distant possibility. The universe was filled with primordial gas clouds and the very first generation of stars. This specific ray of light was the death cry of a massive star from that era. As it collapsed and tore itself apart, it released a beam of light that pierced the darkness, traveling through billions of light-years of expanding space-time. It survived encounters with interstellar dust and the shifting structures of evolving galaxies, refusing to be extinguished until it reached a tiny, fleeting window of detection on our blue planet. When the data reached ground stations, researchers immediately recognized its significance. Its energy curve and redshift pointed to a signal that had traversed almost the entire history of the universe. This is more than an astronomical success, it is a breakthrough in our dialogue with the infant cosmos, revealing how the first stars lived, died, and scattered the heavy elements carbon, oxygen, and iron that would eventually form the mountains, oceans, and very bodies we inhabit today. We are, quite literally, made of the remnants of these ancient explosions. For the scientific community, this observation validates theories regarding early star formation and provides new data on dark energy and the expansion rate of the universe. Every ancient GRB is a timestamp written by the universe itself, and decoding them is the process of humanity tracing its own origins. This discovery also underscores the necessity of international cooperation. Before the vastness of space, there are no borders, only a shared desire to understand the stars. This faint light from 13 billion years ago reminds us that the universe never stops telling its story, provided we are willing to listen. It is a handshake across time, connecting a lonely star from the dawn of time to an ordinary night on Earth in the present day. Yet, as we map this grand design, we encounter baffling gaps. In certain regions, the king of the universe seems to have left unfathomable stretches of nothingness. Imagine a region of space so empty that traveling across it at the speed of light would take over 300 million years. These are cosmic voids, barren realms where the density of galaxies is staggeringly low. One of the most famous is the Boötes void, often called the Great Void. While one might expect to find 10,000 galaxies in a space of that size, we have found only about 60. Its existence challenges the cosmological principle, which suggests that the universe should look roughly the same in every direction on a large enough scale. Even more mysterious is the Eridanus supervoid, which spans 1 billion light-years and is linked to the cold spot in the cosmic microwave background radiation. Some theorists suggest that as photons travel through such a massive void, they lose energy, creating a colder patch in the afterglow of the Big Bang. How do these vast deserts of nothingness form? There are several compelling theories. One involves the concept of cosmic inflation. Shortly after the Big Bang, tiny quantum fluctuations were stretched to cosmic scales, creating regions of slightly higher and lower density. Over billions of years, gravity pulled matter toward the denser areas to form galaxy filaments, leaving the low-density regions to become empty voids. Another theory points to dark energy, the mysterious force accelerating the expansion of the universe, which may act to push galaxies away from these empty spaces, causing the voids to expand over time. Some even speculate on more exotic possibilities, suggesting these voids could be interfaces or gateways to parallel universes within a broader multiverse, or that they are macroscopic imprints of the quantum foam from the moment of creation. While these ideas remain speculative, they represent the frontier of our quest to connect the physics of the infinitely small with the structures of the infinitely large. Whether through the blinding light of a gamma-ray burst or the profound silence of a cosmic void, the universe continues to reveal its complex, ancient, and beautiful architecture to those who look up. Another captivating hypothesis leads us into the abstract and complex realm of topology, a field of mathematical study that describes the properties of space that remain preserved under continuous deformation. In a cosmological context, topological anomalies, or cosmic defects, refer to irregularities within the very fabric of space-time itself. Much like a flaw in a piece of fabric, these defects represent regions where the normal structure of space-time has been disrupted. But where do these anomalies originate? To find the answer, we must return to the inflationary epoch of the universe, a phase of superfast expansion where the cosmos grew exponentially. While this expansion generally smoothed out the distribution of matter and energy, it may have also amplified microscopic irregularities in the geometry of space-time, leading to the creation of these topological defects. These regions could then become areas where matter found it nearly impossible to aggregate, eventually manifesting as the vast cosmic voids we recognize today. Furthermore, no exploration of cosmic voids would be complete without considering one of the most enigmatic objects in physics, black holes. Specifically, we are discussing primordial black holes. Unlike the stellar mass black holes formed by the collapse of massive stars, primordial black holes are theorized to have formed shortly after the Big Bang, birthed from extreme density fluctuations in the early universe. How do these ancient entities relate to our great cosmic voids? Some theorists believe that these voids might actually be populated by a high concentration of primordial black holes. According to this idea, the void is not truly empty but is instead a result of these hidden objects effectively clearing out their surroundings through gravitational influence. Since they do not emit significant radiation, they remain nearly impossible to detect directly, yet their presence could explain why these vast regions appear so barren of visible galaxies. Another theory connects the emergence of large voids to the elusive nature of dark matter. Although dark matter cannot be detected through traditional electromagnetic methods, it is believed to account for approximately 85% of the total matter in the universe. Dark matter plays a critical role in the formation of cosmic structures, weaving a vast and intricate web that connects galaxies. These dark matter fibers, known as filaments, provide the scaffolding for the universe, guiding the formation of galaxy clusters. However, what if something disrupted these filaments? What if a major event or an unknown force caused these structural supports to collapse or disintegrate? This is where the theory of void formation through filament collapse comes into play. According to this perspective, the breakdown of these dark matter threads would interrupt the flow of matter, leaving behind immense stretches of empty space. As we have come to understand, these vast empty regions are far from being mere wastelands. They are treasure troves of clues and mysteries regarding the collective composition of our universe. From the formation of large-scale structures to the behavior of dark matter and dark energy, these mysteries compel us to rethink our fundamental understanding of the cosmos. While we may not have all the answers yet, every question we pose and every void we explore brings us one step closer to unveiling the secrets of existence. Remember, whenever you look up at the night sky, you are not just seeing stars and galaxies, you are also looking at the invisible cosmic voids. These silent guardians of the universe continue their eternal watch, holding the secrets of the cosmos within their vast reaches. That concludes our sharing of knowledge for today. I wish you all peaceful dreams and a wonderful day ahead. We will see you in the next episode.